Hello Calculus and welcome to 8.3. This is continuous money flow, and there's a bunch of different money we're going to worry about, like present value, how much money you need for a total lump sum payout, where your total income is, all kinds of fun things. So make sure you got your notes out, and let's go. Alright, first we'll start with total money flow, then we're going to go to present money flow, and then accumulated money flow is what we're all looking at. So total, present, accumulated. Total money flow, very important. Its total income does not take into account interest. All right, so it's just literally how much money are you getting from 0 to t and of your function. So here we go. Let's talk about a soda machine. Okay, it's growing exponentially. Okay, now that's a clue. Exponentially means that's your initial e to the kt. Remember where k is your constant of variation. When the machine is first installed, it produced an income at a rate of $810 per year. So they're guessing. When they put it in the first day, they think, I'm going to make $810 this year. Doesn't mean it's going to happen. At the end of their first year, their rate was only $797.24. So it was going down. All right, they want to know how much income they'll have in the first 2 years. So is it worth putting this machine here? So they put in a sub 0, e to the kt is our formula for continuous growth. Something you should remember, I'm hoping. Your initial was 810, that's what we think it's going to produce. Our ending was 797.24, that's what we actually got, and that was over a 1-year period. So we put that into our formula and we calculate e. So you divide by 810, remember to get rid of an e, it's the natural log of both sides. And we get a negative 0.015 for k. It's not a good sign because our constant of variation probably shouldn't be negative. But now let's see how much money we're going to make. So from 0 to 2, for the first 2 years, that's where that came from. Our formula is 810 e to the negative 0.015. That's our constant of variation we found in our initial. T, we're going to do our first derivative. So we divide by that negative 0.015 from 0 to t. So in the first 2 years, I'm going to make $1,595.94. All right, when you're thinking about that, it's not bad, but you could probably find a better location since we have a constant of variation that is negative. It's not a good sign. All right, let's see how you do. Same scenario. First machine is earning $1,000 by the end of the year, and the machine is earning $1,020. What's the total income after 3 years? All right. Let's see how you did. First step, you should have created your formula. So this is where I'm ending. 1,000 e to the k, and then t is just 1. Divide by 1,000. So you got 1.02020 equals e to the k. Take the natural log of both sides, and we get 0.02 equals k. Better, at least my constant variation is positive. It may not be large, but at least it's positive. So the first 3 years, we do this. 1,000 e to the 0.02, t for time, dt, do your integration, over your 0.02, all from 0 to 3, and you should have gotten 53,091.83 minus 50,000, and your total was $3,091.83 for the first 3 years. So this is a good location. We made $100 more than we actually thought, or $91. Okay, present money flow. It's the value of continuous money flow with interest. So now how much is my money, what am I earning, plus what my interest is in the bank. Where am I at? We like this formula. Okay, the company expects an annual income for the next 3 years. So this is my income. All right, I'm going to have a 3-year period, and I'm going to assume an 8% growth. Okay, that's quite a bit, but it's not bad. So now we have this formula. This is how much I'm making. This is my interest formula. All right, if you notice, it's by parts because I've got that extra t in there, right? So who should I derive and who should I integrate? And of course, 75,000 t is what we should take the derivative of, and we're going to integrate the e. So we take the derivative until we get to 0, nothing new. We integrate the e. I did the math here to make my life a little easier because I was tired of those decimals. And we got those. Now we're going to multiply. This one's add, multiply, this one's subtract. All right, multiplied, subtracted the next one, all from 0 to 3. Plug in my 0 and my 3, and I've got $288,063.89. That's with interest. Okay, now let's compare this to total money flow. So remember, this is no interest. All right, so we plug in our 0 to 3, and I would have made $337,500. All right, what this is telling you is that the lump sum, this guy right here, is a lump sum investment of $288,064 with an 8% interest would give me a cash flow of $337,500. So I got laid off from work, and I was making $75,000 for 3 years. The insurance company should offer me $288,064 because with interest, that's what I should have been making. I hope that makes sense to you. Okay, pause and try yours. So you should have integrated. It was 5 years from 0 to 5. Here's your function. 50,000 t. My interest is 3.5. So that's e to the 0.035 t dt. Do your integration. So you should integrate the 50,000 t, or differentiate, sorry, and integrate e to the 0.035 t. Again, down till you get to 0 and 0. And this one here is e. I forgot my negative. Sorry about that. I think I forgot to write it up here too. I did, because that's always negative there. E to the negative 0.035 t divided by negative 0.035. I ran out of room. And then we would have e to the negative 0.035 t now divided by 0.001225. All right, I left the decimal this time in the denominator because some of you prefer that, just so you can see it done both ways. So we're going to multiply. This is add, multiply, this is subtract. But remember, there's a negative down here. So this is really negative 50,000 t e to the negative 0.035 t all over 0.035 minus 50,000 e to the negative 0.035 t all over 0.001225. All right, you're going to integrate from 0 to 5. Sure you're using your calculator. This first one, when you plug it in, was a negative. I got 5,996,121 and 577 minus 3426355.87. Okay, now we got to add. So there's your 5. Here's 0. I am so out of room. 4025963.45 plus 4081632.53. If you want to type that all in your calculator at one time, you are more than welcome to if your calculator will do it. That gave me a total of $556,653.08. That was my total lump sum is what they should give me. All right, just for fun, let's calculate total money flow. So the total money flow from 0 to 5, 50,000 T, oh, that's DT, baby, equals 50,000 T squared over 2, all from 0 to 5. Okay, when you type that in your calculator, you would have got $625,000. So this means your insurance company has to offer you this to match that price for 5 years. I hope you did a good job on that. Okay, last but not least is accumulated money flow. Okay, accumulated money flow. We're using PERT. Remember that one? PERT is what you guys seem to call that. Now when we do this here, accumulated money flow is a rate of money flow at an interest rate R at time T. So how much do I currently have in my account is what we're looking for. So let's go through. I have a money flow, continuous at a constant rate of $2,000 per year, 5 years, 6% compounding continuously. So we want to find everything. We're going to do total money flow, accumulated money flow, total interest, and present value. So what do we all end up with? Okay, total money flow is the first one, right? How much should I have? I have $2,000 from 0 to 5 years. Plug it in, and I would have $10,000 with no interest, right? I just make $5,000 per year. Accumulated money flow. Now this is the interest one. So this is no interest, right? No interest. So this is with interest. So now, same thing, but now I have to account for my interest on the outside. So we're going to do our first derivative. I'm going to bring out my t from 0 to 5. So we're going to do the derivative of this guy. I did this one a little different just to show you. I can take out some of those numbers to make it easier. Now we do our integration from 0 to 5. We plug in 5 and 0, and I would have $11,661.96. All I did here was pull out the E and the 2,000. Nothing major, because they were both constants. Total interest, you literally subtract the two. So I made $1,000 in interest. So this is the interest I earned, and that's all it is. Present value. So what's my lump sum I should have if I was not going to do anything? So now we have 2,000 times my interest, correct? We do our integration from 0 to 5. We plug this in, and I should be given $8,639.39 if that's what the insurance company should give to me. All right, your turn. All right, I hope you did a good job. Your first one is present value. So this is just how much you're earning. You started off with $3,000. So you go from 0 to 5, and you have a total of $15,000 earned with no interest. Next, when you calculate with interest, so our interest was 5%. So we're going to go e to the 0.05 for 5 years. 3,000 e to the negative 0.05 t. This is with our interest, right? Factor out our 3,000. Integrate e to the negative 0.05 t from 0 to 5. And we have negative 60,000 plus this. So we have a total earned with interest as $17,041.53. The interest is literally, you subtract the two, and we've earned $2,000.41 in $2,041 in interest. Now, what lump sum should I have if I get hurt? You take the $3,000, your interest earned, do your integration from 5 to 0, and the company should have to pay us out $13,271.95 to guarantee the same income. All right. I hope you did well. Good luck on your homework. Oh, I forgot one. I thought I was finished. Continuous money flow. My fault. Let's go. Okay, starts at a rate of $1,000 per year and increases at 2% per year. I want to find accumulated money flow at the end of 5 years with a 10% interest compounded continuously, which is our E formula. I want to find the present value at 5% compounded continuously. So let's start with A. I am given 1,000. I have a 2% increase. I have an interest rate of 10% that I'm earning, and I want to do this for 5 years. So we know it's 1,000 e to the 0.02t. That's just your formula, right? PERT. All right, my interest rate here is what we're following. FTE to the negative RT. Now, e to the RT, my interest rate was 10% for 5 years. That's on the outside. 1,000 goes out. Now, my rate that I was earning was 2% per at time. All right, e to the negative 0.12t came from our formula. All right, so let's go. This is our 10%, correct? So now we take, and I'm going to take the 0.5 here. I'm going to take the 1,000 out to make my calculations easier. Multiply those together, so you added your exponents. Do your antiderivative from 5 to 0. Plug in 5 and 0 here. And we get $6,794.38. Sorry about that. All right, now let's do our present value. 1,000. 2% is what we're expected to gain. Negative 0.05t from our formula. Bring the 1,000 out. Add your like terms. Do your integration. And our present value is $4,643.07. All right, yours is a little different. It's by parts, so we're going to combine everything here. So, work with a partner if you have one sitting by you. If not, take your time and go slow. All right, I hope you did a good job. So your first part, you set up your integral, so you have your function and your interest. All right, now I did the table method. So we're deriving the first function, you're integrating the e, you're multiplying down, you're adding and subtracting all the way through. I pulled out e to the negative 0.1t because everybody has that in to make my life easier. And now I just did the math, the multiplication, combined like terms on this step, plugged in 10 to 0, and your final answer is $163,245.21. All right, good luck on your homework. Make sure to post questions if you have any.